My name is Rajapaksha RCP. My IT number is 20137250. This video shows using a car price prediction dataset from the Kaggle website and selecting the best model using for machine learning based supervised learning models to predict the car price given relevant features. The four supervised learning models used here are: first one is linear regression, second one is support vector regression, third one is decision tree regression, and last one random forest regression. Let's start.
IT number is IT 20642914. So we are doing car price prediction based on various of features. I am using use these libraries NumPy, Pandas, and Matplot. Scene are imported. And data loading used using the Pandas data frame. Uh, and that dataset includes such as car name, year, selling price, and other data. Uh, Data as a basic inspection of such as checking shape of the dataset and looking for missing values are performed. That data and the data that is found, there are no missing values. And data clean and transition, the car name feature contains many unique values which are reduced to fewer categories into simplify the model. Most of car names are grouped into single name other category and fewer expression. As a feature engineering, we did a year feature is transformed into the age feature to provide more direct measure how old that car is, which are more related to predict the price. And dummy variables like categorical variable converted into dummy variables, which is transformation is necessary because machine learning models cannot interpret with the text data. The transformation is creative new columns where each category is feature gets an own column with filled with binary values. Uh, this is data processing. This is analyzed using the plots, bar graphs. So as a feature section and model training, core correlation analysis is heat pump correlation between the feature and targeted variable is generated to identify the high influence of features. And data set it is split into training set and testing set. This is critical because model on train on the part of the data and testing on the separate part of the data to evaluate the performance. A linear regression model is chosen as a predictive model. Search is conducted find the best hyperparameters for the model. Linear regression is model is fitting using the best performance found through the search grid, and the model predicts car price on the testing set, and metrics such as mean, square error, and confusion determination, and mean absolute error are calculated to access the performance of the model. So confusion determination value of 0.88 indicates that model explain of significant portion of the variance of car prices. So model saving is using a pickle, which is allows to it to be reused for the prediction for without needing to do retrain. So this model is used to predict selling price of a car given its feature, demonstrating how to model can use in real world. Thank you.
My name is SES Arachan. IT 20230692 is my IT number. So according to our NML project, I mainly focus on support vector regression part. So support vector regression is machine learning techniques that predict numeric values by finding the best fitting line or curve in high dimensional space. So using the support vector to determine the optimal separation between data points, it's useful for tasks like predict stock price or housing price also. So according to that, we use the car price prediction. So we can see how affect that. In here we can use several libraries like this, and we can see this is the our data set visualization, and here available 301 rows and 9 columns, and there are no missing values, and this is the data type also. Here some available the string values, so we want to convert that also to integer. So this is the data pre-processing part. Here the available car names is several car names are available, so we cannot use the one hot encode method because there are several lot of car names are available. So we use define function like this. So we use up the 10 values we use as car, and otherwise return as the others. So according to that visualize like this, car names and others, car names and others are in like this visualization. According to that we use year column as well. Year column is available in here, and we use the year column as age. We use current year and reduce the available data in here. So we can view like this age, and the age is like this and integer. So fuel seller and transmission is no need do like this. So and this is the our rename column visualization, and then we use some floats to visualize best uh, view like this: selling price, fuel type according to and seller type, and this is the comparison categorization view. You can see like this bar charts, and then we can see the analysis part. This is the analysis part, also available the 99% available, high, high availability, and this is the also the data pre-processing part. According to we use get dummies, so pre-processing as one hot encode method. According to that we can get the result like this. Now this result can be used for our SCR test, and this is the heat map, and this is the training split available, and y-axis can we can get the selling price, and x-axis get other things, the columns. And then this is the support vector regression part. Import the several important files in here, and then define the hyperparameters here, mainly degree and the regularization parameter as c and gamma, and epsilon is set as here, and then the grid search SVR, and then get the best hyperparameters. These are the best hyperparameters in here. So according to that we use best parameter hyperparameters for our tune. Like this result we can get, and then the mean squared error and the mean squared error and the conflict of determination like this we can see, and then view the plot view according to the actual values and predicted value, how this going on. And then we can see the mean absolute error like 2.85, and then also we can get the price, selling price according to that turn to predict values, uh, and those are the important things how to do test in support vector regression. Yeah, thank you.
Now let's see how to train a model to predict the car price using the decision tree regressor model. First, the necessary libraries should be imported like pandas, numpy, matplotlib, etc. This is a load dataset using the pd.read underscore series CSV method, and this is a preview of the dataset. This dataset include features like car name, year, selling price, present price, etc. And this dataset include 301 rows and 9 columns, and check the null values or missing values. There are no missing values. And this dataset include 2 float variables, 3 integer values, and 4 string values or object values. All categorical values must be converted into numerical values for ease of identifying the model. One-hot encoding technique is used for this. And this is a data pre-processing technique. The large count in car column is pre-processing. The smaller count is for ease of using the one-hot encoding technique. And length is 6, like other city, Coral Atlas, Verna. And existing years in the year column is subtract from 2024 and pre-processing the new column, name, age, and drop the year column. And this is a univariate analysis section using these scatter plots, bar graph used for comparing the categorical variables, and a count plot, and box plot. And this is a data preparation section using one-hot encoding technique, pd.get underscore dummies method. And this is a preview of the one-hot encoding dataset. And this is a multivariate analysis used for heat map. And this is a data correlation section for the selling price. And this is splitting the dataset from features and target variables. X contains all columns like age, fuel type, car name, express selling price. Selling price contain Y variable. And this is split the data into training and testing data using scikit-learn library. Training set is 80%, testing set rate 20%, and random testing is 1. And this is the print the training features, training labels, testing features, and testing labels. And finally, import the decision tree regressor. This is defined hyperparameters like max depth, mean sample split, and mean sample leaf, and get the base parameters like max depth is 20, mean sample leaf get 1, mean sample split is get 2, and train the model with the base parameters and make prediction using the testing set. Mean squared error, R squared value, and mean absolute error used for evaluate the performance of the regression model. And this model mean squared error is 0.97, R squared value is 0.96, and mean absolute error is 0.58. And this is a plot of actual versus predict values. Let's see how to train a model using a random forest regressor. First, import libraries and load dataset. This is a preview of the dataset and check the missing values. And this is a data pre-processing section as done in previous model. And this is a univariate analysis section. And this is a data preparation section using the one-hot encoding method. And this is a multivariate analysis using heat map, and train test split, 80% training and 20% testing. And finally, import the random forest regressor. Define the hyperparameters like n estimators, max depth, mean sample split, and get the best parameters like max depth is 9, max features log 2, mean sample is leaf 1. And train the model with the best parameters and make prediction using a testing set. And this model mean square error is 1.18, coefficient determination or R square value is 0.95, and mean absolute error is 0.66. And this is a plot of actual versus predict value. This is a comparison of the performance of the models. The best model is decision tree regressor. Low mean squared error, high R squared value, and low mean absolute error. In summary, the decision tree regressor emerges as the suitable model for predicting car price. Using decision tree regressor model, we create car price predictor website. Input present price 4.15, distance is 5 to 0, pass owner 0, age is 13, car name is other, fuel type is petrol, seller type is dealer, and transmission is manual. And click predict price. The predict price is 2.85 lakhs. This is same as this 2.85 selling price. Present price 1.15, kilometers 5 to 0, same as this I entered. Thank you.